Welcome back. Let's now see the work for this system. You have two forces here, force applied and force of gravity. So you have to compute work done by both forces. Let's first look at the applied force. This is the applied force vector. And the force of gravity vector is the following. Its horizontal component is 0 newtons and its vertical component is -5 sine 30 degrees newtons. Alright? The displacement vector is the following. The x component is 20 times cosine 30 degrees and the y component is 0 meters. Alright? So the work done by the applied force is computed like this. The applied vector dot the displacement vector, which is this one times this one, and then you add, and I'm going to continue writing here, you add this component, 5 sine 30 degrees, times this component, 0 meters. As a result, this term will be 0, and you're left with 5 times 20, which is 100, times cosine 30 degrees squared. And that will give you 75 joules. So cosine 30 degrees squared equals 0.75. Now that's only work done by the applied force. How about the work done by the force of gravity? So you have the force of gravity vector times the displacement vector. So you have 0 times 20 times cosine 30 degrees, which is this element times this element here, plus -5 times sine 30 degrees, which is this element here, times 0 meters, which is this element here. And you can see that both terms are 0. So work done by the force of gravity is 0 joules. And it makes sense because does the ball move in the direction of the force of gravity at all? It doesn't. It only moves horizontally, but the force of gravity is vertical. And work depends on the product of the force and the distance. The ball must move in the direction of the force, at least a little bit, in order for this force to do some work. If it doesn't, then there is no work. And remember, the dot product gives you a scalar, and scalars are just numbers, and so you can just add them together, which means that the work total equals work done by the applied force plus work done by the gravity force, and since this one is 0, then you only have 75 joules, like this. And so that's why in physics you can just add energies, because energies are scalar, they're not vectors. Energy doesn't have a direction. It's just a number, a quantity, and that's why you can add them together like this. So in this system, the only thing that contributes to total work is the horizontal component of the applied force. So that's all about the dot product, and now in the next video we're going to start talking about the cross product. Thank you very much, and I'll see you there.